4, I'm recording here, and you can go and check the mascot guy. So he's inside the lecture. Oh, yeah, he's inside the lecture. So yeah, you can look at the video there. So chapter 4 will go over the development of the population throughout the urban cities and the rural cities as well, and how is the impact on this the impact of this, growing out of the cities to the villages and the farm, and how the impact of those cities on the population well-being. Those cities are becoming very crowded, and the question is, are those resources enough for those ever-built cities? That's the big question of this chapter. Do we have enough resources to recover the population in those cities, which is grown in a very fast way? So now we have this book. You can see is up to 1900 to 6 billion. Well, now we are not 6 billion. We are around 7 billion, correct? The latest one about 7 billion something. So you can see the population. Even the book is written a little bit using a lot. 6 billion 2000, but now 2025 is 7 billion and something. So 7.4, 7.3, something like this. So in up to 2000, the population was 6 billion. In 1211, the United Nations announced that we had reached 7 billion. That's correct, and more now. 2011, and that's what I said, 7.3, 7.4, something like this. Having added the most recent billion in only 12 years, we are now growing at 1.08% per year. So that's the question, whether the human population will continue to grow at this rates or at these rates, what this would imply for environmental quality and human life, among the most central questions in the environmental science. And that's the major thing is. And for the question at the end of the chapter, it's doable if we treat the environment with a lot of respect, and if we sustain our resources around us. So it's doable. So the population can go and grow higher than this. As you can see, it's predicted it's maybe up 2050 or something, up to 12 billion maybe. But it's sustainable if we have the correct attitude towards the environment and towards sustaining the environment itself. Human population grew slowly until recently. A population of early hunting and gathering societies probably numbered only a few million before the invention of agriculture 10,000 years ago. That's a fact. That's really true. Now you can see how the whole thing is the number is going very fast. Human population began to increase rapidly after about 1600 AD. It took 156 more years to get 3 billion in 1960. It took us about 12 years to add 7 billion. The number of living humans tripled during the 20th century. So if you look at the material inside chapter 4, you will see they are predicting by 2050 or something about 12 billion. And there are some scientists are going that we reach by this value, the highest max that the Earth can sustain humans and the whole resources with it. Human population throughout the history This is the agricultural revolution here, the beginning. And then it goes to the pharaohs, the Egyptian pharaohs with the pyramids, the Roman Empire, and the Industrial Revolution era. So all this here, you can see it with the years here at the bottom, and the population growth. You can see how the growth is. Then, if you can see here, I can show you here. Just look at this. The growth with the mechanical industrial revolution in mechanical and industrialized technologies, it went out to here. The Roman Empire, if you look up to here, the Egyptian up here, the whole thing here, I think is maybe. So you can see the difference between. You can read the difference between those numbers here. You can see that's the revolution. The industrial revolution is the highest by far is the highest jump. By far is the highest jump between those. So, and you can. This is about this one here, about five, I think, in billions, 5 billions. Okay, and this is almost less than 1 billion, less than. Can see it here very well. So yeah, that's very few. That's few millions here. So it's here. Those are few, not billions, few millions. You can tell from the graph number here. The number very close to zero here. And then the top is 5 billion. So the number you can read there. So the growth is very, very rapid within, I mean, if you can calculate how many years that might be here. You can calculate the difference between this. If we are ignoring the, we can include this one here. You can see the difference in the years. Make subtraction, you can see that's the highest number here. You can see how many years we jumped into 5 billion. You can see it by making the difference, how many years the difference. Then you can see that those 5 billion was really present or created within this amount of time at the bottom. It's very rapid. 5 billion is really comparing with a couple of millions at the beginning of the humanity. Now you have 5 billion. You don't have 5 billion nowadays. Nowadays you have 7.3 or 7.4 billion, and by 2050 maybe you have up to 12 billion. So even is increasing. You will be out of the graph. If you look, you will be out of the scale. Scale goes to 7 billion, but we are in 2050 about 12 billion. So then here give you the world population growth and doubling times. So here give you this, whatever is from the graph, whatever you have seen in the graph. That's here just indirect translation, whatever you have seen in the graph, correct? So perspectives on population growth. As with many topics in environmental sciences, people have widely differing opinions about population and resources. As I said, some people, they said if the population goes to 12 billion, the whole thing will collapse. That's really true if, and this is conditional if we really don't know how, or on purpose destroying our environment, destroying all the resources we have quickly. That's conditional. If we do this damage to the environment and to ourselves, then yes, the 12 billion will be enough to destroy the whole. There will be no life there because there are not enough resources available. But if we manage wisely those resources and try to sustain them for a long, long time, we can even surpass the 12 billion population number, maybe higher than that. So it's always in the hand of the mankind to control the destiny of itself. So that's very true. Some believe that the population growth is the ultimate cause for poverty and environmental degradation. As I said, some people will believe in that. Some people, when I say people, that's scientists. The scientists believe that population growth might lead to a cause of poverty and environmental degradation. That's sometimes scientists. Sometimes some scientists will argue with this and say, no, that's not true. So it's the point of view of whatever you see. If you can sustain the environment, sustain the resources available to you, you can live longer life and you can have more population on this globe. But if we are poorly sustaining our environment and our resources, then that's whatever it says, that's true. That's really true. So others, as I said, argue that poverty, environmental degradation, and overpopulation are merely symptoms of deeper social and political factors. And that's really true. So all those factors are really affecting the population growth and well-being. So the worldview we choose to believe will profoundly affect our approach to population issue. And that's what I said. That's really true. Do large families cause poverty, or does poverty cause large families? Well, this is an issue. This is an issue. As I said, it's always the answer. It depends from what the scientists are looking, or what the points the scientists are looking for. So large families cause poverty. That's not always true. That's not always true. That's not always true. Does poverty cause large family? That's not always true. So that's my opinion as a scientist. Both of them interconnected, but not always true. As I said, it's the mankind has the way to shape its well-being and its maintenance of the resources around us. So, since the time of Industrial Revolution, individuals have argued about the causes and consequences of population growth. In 1798, Thomas Malthus hypothesized that the human populations would outstrip their food supply and collapse into starvation, crime, and misery. And that's not happened. That's not happened. As a matter of fact, some diseases appearing in the Middle Ages time killed millions of people, just the diseases. So there's some other factors we have nothing to do with the disappearing of humans. A few decades later, Karl Marx presented an opposing view that population growth resulted from poverty, resource depletion, pollution, and other social illness or sickness. What is carrying capacity for humans? Well, as I said, the 12 billion, maybe they said that's the maximum that we can go. I will not agree. I will disagree, because that's not always true. Always the answer is how it comes back on us, how we treat the environment, how we sustain the environment and sustain ourselves. So we can live more than longer time, and we have the population over even 15 or 20 billion if we maintain the the environment and the resources very well. So here's Cohen at Rockefeller, that's a scientist, university, reviewed published estimate of the maximum human population size the planet can sustain. So estimates spanning 300 years of thinking, it's on a medium of 10 to 12 billion. As I told you, I disagree with this because it can be less than even 7 billion, depending on how we treat our environment, how we treat ourselves, how we are treating the whole resources issue. So that's, as you will see, some resources are really depleted; they'll never come back. But some resources they are in the recycling mode, correct? They are like fresh tap water, correct? That cannot be depleted or gone away because you have always this cycle of the tap water all over the earth is always recycling itself, correct? So but some of those resources are depleted, like minerals, correct? Those are crude oils, okay, and all this natural gases coming from nature, not from manufactured gases. Those all gases made by nature. So those are in the edge of, not really in the edge of depleting itself, but it takes several hundreds of years to be depleted. But can we recycle those? Yeah, the answer, my opinion, is yes. So, Biomental, that's another scientist at Cornell University, states that by 2100, current trends continue, 12 billion miserable humans will suffer a difficult life on Earth. Do you agree? I don't agree. I really disagree because it depends on how the mankind will treat itself.
How the what?
The mankind, the humans, take this issue. If we treat the environment badly, and it's always saying what goes around has to come what? Around. So if you treat the environment and your resources badly, they will come back, hunt you back, and then it come back to you. You will be out of resources. How then you can survive without resources? So that's, but if you can maintain those resources, have them in a very good, under really close observance and good, excellent regulations, I don't think that 12 billion will affect the well-being of the earth and its material resources, including the humans in it. So that's my opinion. As you said, we went further. They said that Martha that said we will have misery, correct? He hypothesis that we have a misery and everything, but that's not happening. We have poverty, we have this, but still that's because of those miseries and everything. That's human-made. That's a bad behavior by humans, not by anything else. That's bad behavior by humans affecting the resources, affecting the sustenance of those resources and distribution of those resources, and affecting of the well-being of humans. So technology increases carrying capacity of humans. That's really true. And that's when most of the scientists will neglect that. We should not neglect the technology that really facilitates all these recycling techniques and all these procedures and methods of recycling, sustaining those resources. Technology will come in a very great help to maintain this globe, the Earth. Optimists argue that Malthus was wrong in his. That's me. I'm one of those optimist people. So I'm very optimistic. That's the mankind will come to the point that really here is the end of it. We have to, from now on, We have to treat the environment rationally. We have to act very rationally, and we have to maintain these resources, and with the way that we have tough regulations and policies, and we invent some new technologies that are helping us to sustain those resources for further longer time. So I'm one of those here optimists. That's I'm arguing against Malthus here. I'm not saying he's wrong, but I'm just saying that he has his point, and his point is correct if there is conditional if. That's if we lose track and we lose this control on those resources, their maintenance, their sustenance, their distribution, then that's what he's saying is correct. That's correct what he's saying. But if we have a very decent policies and regulations and good ways of sustenance of the resources, then I think that's not true. We'll survive this. So he said in 200 years will be a disaster, poverty, famine, and all this stuff. So, but he failed to account for scientific and technical progress. And that's what makes me one of the optimists. That I feel that scientific technology will help us to maintain our resources and to recycle them very rationally. Since the progress in agriculture, productivity, engineering, information technology, commerce, medicine, sanitation have made it possible to support approximately 1,000 times as many people per unit area as was possible 10,000 years ago. We will continue to find technological solutions. I think yes, as long as we have research and development are ongoing. Both of those, R&D, research and development are ongoing. Then I will say yes, there will be a solution. There will be always the solution. Calculating the impact of human population. Well, the impact is given as PAT, the environmental impact, which is the I is the environmental impact I, P equal P. P is I is the product of that's the impact itself, correct? Environmental impact. P is the population size. Influence is or affluence is the wealth. Affluence means the wealth is A, and then T is technology. So this is a formula made of three things here. Is the population size, correct? Population size. Then is affluence, wealth. And then T is for technology. Technology. So if you have those, a product of this technology, wealth, and population size, you can calculate roughly the environmental impact. This is a formula. You don't have to memorize it, but at least you know how the scientists in the environmental science calculate the environmental impacts. Three items. One is the population size. You multiply it by the affluence or wealth of the people, and then multiply it by technology level or the technology. So if you multiply those three items and you have the numbers there provided from the United Nations, then you can see the environmental impact on, as a matter of fact, in each continent and each country. So you can calculate this. But those it's very hard sometimes to find all those data, the three major data here, especially when it comes to The population size is easy to find from the United Nations. The technology is very hard, as some countries they might not give you really all the information about their own technology because of the competition, and the wealth is even difficult to really get good accurate data for wealth for each country or each continent. So, but at least that's a crude formula, so you can calculate the environmental impact. So a family living in a very rich city side, like in the United States, could cause greater environmental damage than a whole village of African hunters and gatherers. So that's what the note of this. So it's all of about these three technologies, and the environmental impact. If you have one is increasing and keeping the other constant, that will affect the impact will increase. So here it is. Just from the math, if you recall the math, I, P multiplied by A multiplied by T, correct? Population, affluence, and technology. Now, if you keep one of them constant, for example, you kept the constant, the population will not increase, constant, correct? Keep constant. And the wealth is constant. You increase the technology, you increase one of them. One technology, well, this kept constant. So if one of them constant and the two of them constant, one is increasing, then the I will increase. How about you increase all of them at the same time, then the I will be increased to the triple times. Correct? That's just a math formula. So if you increase one of them, keeping the other one constant, they all increase. But if you increase three of them at the same time, you will triple the amount of the environmental impact. As I said, you don't have to memorize this. And I did not know about the final, but I don't think so the final will ask you about calculation, because those data is, unless it's made up data, yes, but for me, those data is very hard to find. You find one and you don't find the others because of the competition, like technology. You'll not find all countries will give you their own technology level or progress because of the competition. Ecological footprint can calculate impact. Another way to estimate our environmental impact to express our consumption choices into equivalent amount of land required to produce goods and services. So this is, first of all, we have this formula, I equal the P, population multiplied by affluence multiplied by technology level. So that's the formula. The other one, we can use ecological footprint, meaning you can express the consumption of the consumption choices into equivalent amount of land required to produce goods and services. So if the people are consuming too much, then you can see that they will require larger land, correct? And they will and they're requiring larger land means they will produce larger amount of goods, and they will need larger amount of services. So that will have another way to calculate the impact, correct? This gives us a single number called our ecological footprint, which estimates the relative amount of protective land required to support each of us. As I said, for example, forest and grassland store carbon, protect watershed, purify tap water, and provide wildlife habitat. So that's another way let's say to estimate, not really to calculation, because that's your calculation is estimation. It's not really 100%, because you can consume larger amount of goods, then you require larger amount of land. But that's not always 100% is in in agreement with this each other. That's just an estimation, correct? So you might have in land a lot of other resources will give you that land, and you don't have to add more land to it. So more land to it and expand in capturing more lands. So it's a very crude estimation. It's not really accurate. The same thing with this the formula I equal P multiplied by A multiplied by T. All those crude estimation is not really the environmental impact cannot be calculated 100%. Population growth could bring benefits. Yes, I do believe. However, some scientists will say no. Population growth will bring misery, poverty, famine, all of the above. And that some scientists will believe that. But I do believe population growth really has a lot of benefits. Now imagine that we can't replace the old generation cannot be replaced quickly. Are you following me here? There is a time to replace. Takes time to replace those elderly. So what will happen then? You get this lack of time will have a very negative impact on us and on our resources and our technology and our everything. So you have to have, like you are replacing those who will be retired. You have already those retirees. They have their replacement already intact. You don't have to wait for a couple of years, 5, 6 years, 10 years to replace those retirees. That's not a good policy. You have those retirees, you know them. So that's an example. That has an impact on the environment, on ourselves, on our resources, on our everything. So population growth is very important to replace whatever already died or dead. So died or already dying or already dead, you have to be replaced. How? By population growth. That's the only way you can replace the dying or dead human, and even replace the retirees. So how you come in the world to replace retirees if you don't have enough population? So that's very important. So it also means more people means larger market, more workers, and efficiencies of scale in mass production of goods. That's true. And replacing older work people. So that's not there in the PowerPoint, but you can add it to it. It will not come in the exam something, but it's very important to replace the work body. So you have to have people ready to take over. Yeah. Also means more people to find new resources and better solution to problems. Economist Julian Simon believed that people are the ultimate resource. That's, I agree with him 100%, maybe 200%. That's really true. Your resources is your people, and you need those people. You need those people. So, and that no evidence shows that pollution, crime, unemployment, crowding, the loss of species or any other resources limitation will worsen with population growth. And I agree with that 100%, 200% maybe. And that makes sense. You have to have a replacement ready to go. Whenever is a replacement needed, they are human. They come, will take over. Replace those already dead or already retired. What determines growth rates? Demography. And that's as you see, that's really true. Demography encompasses vital statistics about people such as birth, death, and where they live, as well as total population size. So living longer has profound social implications. Well, that's the opinion of some scientists. I might not agree with that. So age class, why? Because I'm in 2 months, in 1 month, man. Yeah, in about one and a half month, I will be 70. Everybody's following? I will be in 1.5 months, 70 years of age. So I feel like I can produce even more. So I'm not retiring now. Maybe after I hit my magic number, 30 years of service. So I'm here 27 years of service until I hit the 30, then I'll retire. So I can still produce. So that's the whole thing. So age class histogram can show differences between different ages of people in a population, illustrate the social implications of population growth. Those diagrams can be used to determine dependency ratio, the number of non-working compared with working individuals in a population. In Niger, for example, each working person supports a huge number of children. In the United States, by contrast, the declining working population is now supporting an ever larger number of retired persons. See, that's the way you can look at it. And this is just world largest countries. You can see, if you look here, China and India will remain the largest countries with the population. You can see China will be exceeded by India. By 2050, India will be the largest, 1.6, while China remaining second, will remain second. But it is first now, up to 2020, until now 2025 still. But 2050, India will take over. United States will remain as is, the third place. Okay, but the population will increase as well, but not that large compared with India. India is the largest. And then you have the largest jump, India and Nigeria. Nigeria will jump from the 9th, whatever, the 10th, 9th or the 10th one, to the fourth position. So you can see Nigeria and India, those will have larger amount of population. I mean, increase, they will increase, so they will increase. Fertility has declined in recent decades. You have zero population growth, defined as when the birth plus immigration in a population just equal death plus immigration. So zero population growth. What's zero? This is equal when birth plus, so you can put it as this here. Put it as equation here. Birth plus immigration equal death plus this is immigration, and that's immigration, E. So when you have those, that's you have zero population growth. That's they are equal, and I think it's somewhere when they overlap somewhere here. I think when they overlap here somewhere. I think when they overlap here, you have to have an overlap. When they overlap, then the same thing. So high income. Okay, so whenever you have an overlap, I think the overlap will be coming here. So this area, this will be overlapped. So whenever you have overlap, so the rates of the birth plus immigration equal death and emigration. So that's you have a zero population growth. So Fertility rates have declined dramatically in most regions of the world over the past 50 years, while the world as a whole still has an average fertility of 2.6. Growth rates are now lower than at any time since World War II. So that's the whole thing is I mean the birth rates are really declining. The birth rates are really declining, and therefore the population is not increasing as such. That's big. But as I said, whenever we have seen this, the population growth predicted by 2050, this India and Nigeria will have the highest one, the highest rate. Total fertility rates impacted by culture, yes. The total fertility rate is number of children born to average woman in a population during her entire reproductive life. Well, in some countries, they are really honor to have more children because they use their children to help the family in their farms, in their cultivation crops, and they are really a good helper and good really sustenance for the family. So they are really an asset. So therefore, the more children they have, the more or the best condition they might have. So in some countries, especially in the farm areas of that country, you'll see those areas in those farm countries. In the countries they have a lot of cultivation of crops. They need a lot of manpower because they are missing what technology is not there to replace a human work. So the rate varies according to many factors, including education, access to modern health, and religious practice. That's the rate of fertility rates. Life expectancy is rising worldwide. Lifespan is oldest age to which a species is known to survive, and life expectancy is the average age that newborn infant can expect to attain in any given society. So fertility is influenced by culture. A number of social and economic pressures affect decisions about family size, which in turn affect the population at large. So I told you about this in areas in some countries they need manpower. They need a lot of people helping them to helping them in farming, farming and in all the cultivating the crops and all the stuff. So they need a lot of children. Often children are valuable to family, not only for future income, but even more as a source of current income and help with household chores. So that's what I said. That's what is in some countries, not all the countries, especially those countries are missing a lot of technology. Technology is not there, so they replace it with the manpower. Society also has a need to replace members who die or become incapacitated. Education and income affect their desire for children. Highly developed countries, higher education and personal freedom affect women to not have children. The desire to spend time and money on other priorities limits the number of children. Thus, in developed countries, in the developing countries, feeding and clothing is minimally expensive. Adding one more child is negligible compared to the cost in the developed countries. And that's what I said. In the developing countries, the number of children is sometimes a prestige. So the more children they have, the more prestige they have, because they need the manpower to help them on the field. There are no technologies there to help them, so they need the manpower. So more children were born, and that's a prestige for the family. They have now workforce to help their families. That's in the developing countries. This demographic transition, you can see from 1920 up to 1995. It's about maybe 75 years. You can see it's coming to demographic transitions. Comes here. We can look at this demographic transition, and then you have when in the 20s happened the depression, 1920s. You heard about the Great Depression, so the population went. I mean, the whole thing, the economy went down, and even the population growth went down. And then you have baby boomers era in the 60s. And then now, from now on, you have an echo boomers. Okay, that's here in the 70s, 1970s. And here's birth per thousand population. This is the birth. So you can see in the 20s, it's 18.4, but 1960, that's went down here. That's when the depression. So now we are in the age of 15.9. So it's really stabilizing from 18, and after the depression time in 1963 was 18.4, and now we have 15.9 in 1995. So it's almost stabilizing the birth of those children. Let me take this one out. This is here stage of economic and social condition, change mortality and birth. Stage 1 represents the condition in pre-modern society, and you don't have to worry about. Those are the stages here. Stage 1. This is stage 1. So from here to here, stage 1, you can see almost identical. This is the pre-modern society, and now stage 2, from here to here. This is this one here. You will see a decrease going down. Stage 2 is a decrease. Let me see. And this is the blue one is the crude birth. Oops, sorry. This is the birth rate, the blue one, and the red one is the death rate. So at the beginning, and here you can see the death rate, and here is time. Here you have time. So at the time progresses, at the first stage they are equal. The rate, I mean, of birth of the birth equal the rate of death. Then in stage 2 is decreasing. Both of them decreasing. Both rates, birth rate and death rate, are decreasing. In stage 3, even decreasing further here. This is stage 3, this further, but the death rate is even lower than, see here, that's lower than the birth date. That's stage 3. Stage 4, let's see stage 4 here. Stage 4, they will see what, now that's equilibrium. That's they come, both rate, the birth and the death are, the rates are equal. Okay, so that's what it says in the, so stage 2, can see it's a decrease, but the decrease of the stage 2 here it is, the rate of the death rates increase in this stage 2 sharply. This one decrease, but small amount. And this trend will come even further, will further decrease stage 3. And stage 4, you reach equilibrium. Both rates are equal. Okay, guys, so I'm going out of this one here. Okay, guys. Many countries are in the demographic transition. Some demographers claim that the demographic transition already is in progress in most developing nations or countries. They believe that a lag between falling death and birth rate may hide this for a time, but that the world population should stabilize sometimes in this century. That's when you get the two rates, rate of the birth equal the rate of the death are almost identical. That's when you have reached the demographic transition. Some countries have had remarkable success in population control. Thailand, China, Colombia, for instance, total fertility dropped by more than half in 20 years. Morocco, Jamaica, Peru, and Mexico all have seen fertility rates fall by 30 to 40%. So improving women's lives helps reduce birth rate. Yes, that's true. A board consensus reached by the 180 participating countries at 90 abroad consensus, 1994. Conference on Population and Development agreed that the following are necessary to help slow population growth. Those are three. Ones are helping the slow the population growth. Responsible economic development, education, and increase women's rights, high quality health care, including family planning services. Those are the three ones. They are slowing the birth growth, the population growth. Family planning gives us choice. Yes, that's always true. And the birth control, that's always true. Those two items are really controlling the birth rates, controlling the birth rates of new infants. What kind of future are we creating? Well, lots of scientists, demographers believe that world population will stabilize sometime during this century. I don't agree with that, although that might be true, but I think we will see a growth in the population. Not they said about 10 billion, but I think it will stay growing until maybe reach 12 or 15 billion. Then it's a matter of how we sustain the resources and how we manage the resources around us. So the United Nations Population Division project the possible populations, 4 possible populations, and you can look at those in the picture there in the PowerPoint, detailed PowerPoints. Takeaway points: a few decades ago, we were warned that a human population explosion was about to engulf the world. However, birth rates have fallen, almost everywhere, and most demographers now believe that we will reach an equilibrium around 9 billion people in about 2050. So that's what they think, 9 billion or 10 billion, but that's just estimation. But I think we will be exceeding in even 15 billion in hundreds of years from now. We'll exceed that. The 12 billion or the 15 billion, that's the maximum the Earth can sustain. But that's not always true. That's just their estimation of that. However, if we should carry out family planning and utilize birth control, remains controversial. How many humans our planet can support on a long-term basis also remain a vital question. And that's what I said. to answer this question, well, it depends on the mankind itself. The mankind can destroy itself quickly. The mankind can stay for thousands and thousands, maybe millions of years to come, and the population will grow. But as long as there is regulations, policies controlling the sustenance and controlling the sustenance around us and the resources around us, I think we can grow out of this 15 billion, whatever they decide is the maximum load that the Earth can have. We can grow out of it. So I'm not going to chapter 15 because the time. Oh, I can. This is 5 minutes if you can allow. We have still 8 minutes.